This video will cover difficult part 2 questions regarding the topic of derivatives trigonometric functions. Number 1, f of x equals, we can rewrite as sine x over 2 squared. Think of it as u equals sine x over 2. Then f prime of x equals, u squared prime is 2u times u prime. The inner function is sine x over 2, sine x over 2. Then 2 sine x over 2 times, now u equals x over 2, then sine u prime equals cosine u times u prime equals 2 sine x over 2 times cosine x over 2 times x over 2 prime is 1 over 2. Sine 2x equals 2 sine x times cosine x. So 2 sine x over 2 times cosine x over 2 equals sine x. Then this one is sine x, then 1 over 2. Then f prime of pi equals 1 over 2 sine pi is 1 over 2 times 0, which is 0. Use derivative of the function of f at the point x equals a. F prime of a equals limit as x approaches a, f of x minus f of a over x minus a. Then we can think of it as f prime of a equals limit as x approaches a, f prime of x minus f prime of a over x minus a. The question, limit as x approaches pi, f prime of x over x minus pi, we can rewrite as limit as x approaches pi, f prime x minus 0 over x minus pi equals limit as x approaches pi, f prime of x minus 0 equals f prime of pi over x minus pi equals, use this one, f second prime of pi. F prime of x equals 1 over 2 sine x, then f second prime of x equals 1 over 2 cosine x, then f second prime pi equals 1 over 2 cosine pi is 1 over 2 times cosine pi is minus 1. The final answer is minus 1 over 2. Number 2, y equals square root of u is a differential function of u. So y equals u to the power of 1 over 2. Then dy du equals 1 over 2 u to the power of 1 over 2 minus 1 equals 1 over 2 u to the power of minus 1 over 2 equals 1 over 2 times back to the radical form 1 over square root of u, which is 1 over 2 square root of u. U equals tangent cubed v. We can rewrite as u equals tangent v to the power of 3 is a differentiable function of v. Then du dv equals, think about this one is u, then 3u squared times u prime. The inner function is tangent v, then 3 tangent squared v times tangent v prime equals secant squared v. Then v equals x over 2 is a differential function of x. Then dv dx equals 1 over 2. When x equals pi over 2, v of pi over 2 equals pi over 2 over 2, which is pi over 4. Then u of pi over 4 equals tangent pi over 4 to the power of 3 equals 1 cubed, which equals 1. dy dx equals, we can rewrite as dy du times du dv times dv dx. Then dy du equals 1 over 2 square root of u times du dv equals 3 tangent squared v secant squared v times dv dx equals 1 over 2. Then dy dx, when x equals pi over 2, then v equals pi over 4. That means u equals 1. So 1 over 2 square root of 1 times 3 times tangent squared pi over 4 secant squared pi over 4 times 1 over 2 equals 1 over 2 times 3 times, use the triangle 1 1 square root of 2, then tangent pi over 4 equals 1, then squared, then cosine pi over 4 equals 1 over square root of 2, then secant pi over 4 equals reciprocal of this one, then square root of 2 squared times 1 over 2 equals 1 over 2 times 3 times 2 times 1 over 2 cancelled. The final answer is 3 over 2. Number 3, y equals the square root of 1 plus u squared is a differentiable function of u. Y equals 1 plus u squared to the power of 1 over 2. Then dy du equals 1 over 2 times 1 plus u squared to the power of minus 1 over 2 times 1 plus u squared prime equals 1 over 2 times 1 over square root of 1 plus u squared times 2u, then cancelled, then u over square root of 1 plus u squared. U equals 2v plus 3 over 2v minus 3. Then du dv equals, use the quotient rule, 2v plus 3 prime times 2b minus 3 minus 2b plus 3 times 2b minus 3 prime over 2b minus 3 squared equals 2 times 2v minus 3 minus 2v plus 3 times 2 over 2b minus 3 squared, then expand 4b minus 6 minus 4b minus 6 over 2b minus 3 squared equals, cancelled, minus 12 over 2b minus 3 squared. v equals sine of x is a differential function of x, then dv dx equals cosine x. When x equals pi over 6, then v of pi over 6 equals sine pi over 6. Then use this triangle 1 2 square root of 3, then use the SOHCAHTOA, which is 1 over 2. Then u over 1 over 2 equals 2 times 1 over 2 plus 3 over 2 times 1 over 2 minus 3 equals 1 plus 3, which is 4, 1 minus 3, which is minus 2. The final answer is minus 2. dy dx equals, we can rewrite as dy du times du dv times dv dx equals the first one, u over square root of 1 plus u squared times the second one, minus 12 over 2b minus 3 squared times the last one, cosine x. Then dy dx, when x equals pi over 6, then b equals 1 over 2, then u equals minus 2 is minus 2 over square root of 1 plus minus 2 squared times minus 12 over 1 minus 3 squared times cosine pi over 6 equals, make positive 2 over square root of 5 times 12 over minus 2 squared, which is 4, times cosine pi over 6, use this triangle, square root of 3 over 2 equals, cancelled, this is 3, then 3 square root of 3 over square root of 5, then rationalizing the denominator times the square root of 5 on each side, 3 square root of 15 over 5. Number 4, the first curve y equals 2 sine x, then y prime equals 2 cosine x. The second curve y equals sine 2x plus k, then y prime equals cosine 2x times 2x prime, then cosine 2x times 2. They are tangent to each other. That means these two y primes are the same. So 2 cosine x equals 2 cosine 2x, then cancelled. Then cosine x equals cosine 2x equals cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. We have to choose this one because it's only terms of cosine x. Then back to the original, 2 cosine squared x minus 1. We can rewrite as 2 cosine squared x minus cosine x minus 1 equals 0. Then we can factor 2 cosine x plus 1 times cosine x minus 1 equals 0. That means cosine x equals minus 1 over 2 all 1. When cosine x equals 1 over 2, that means reference angle equals pi over 3. But cosine x is negative, 1 quadrant to 2 and 3. So make the triangle like this. And then this one is pi minus pi over 3, which is 2 pi over 3. And then this one is pi plus pi over 3, which is 4 pi over 3. And cosine x equals 1 when x equals 0. Then the first one, when x equals 2 pi over 3, then 2 sine 2 pi over 3 equals sine 2 times 2 pi over 3 plus k, then 2 times sine 2 pi over 3 is square root of 3 over 2 equals, this one is sine 4 pi over 3, which is minus square root of 3 plus k, then k equals 3 square root of 3 over 2. This is the first k. And the second one, when x equals 4 pi over 3, then 2 sine 4 pi over 3 equals sine 2 times 4 pi over 3, then plus k is 2 times minus the square root of 3 over 2 equals sine 8 pi over 3, which is the square root of 3 over 2 plus k, then k equals minus 3 square root of 3 over 2, and then number 3, when x equals 0, then 2 sine 0 equals sine 2 times 0 plus k, then 2 times sine 0 equals 0 equals sine 0 is also 0 plus k, then k equals j. This is the last one. Number 5, use the quotient rule. Y prime equals sine cubed 5x prime times cosine to the power of 4 over 5x minus sine cubed 5x times cosine to the power of 4 over 5x prime over cosine to the power of 4 over 5x, then squared. Let's first differentiate only the part where the chain rule should be used. This is the first one. Then sine 5x to the power of 3 prime equals, just think of it as inner function is u, then u cubed prime is 3u squared times u prime equals 3 sine squared of 5x times, now 5x is u, sine u prime equals cosine u times u prime is 3 sine squared 5x times cosine 5x times 5. The final answer is 15 sine squared 5x cosine 5x. Then second one, cosine 5x to the power of 4, then prime equals, think of it as this one equals to u, so u to the power of 4 prime is 4u cubed times u prime equals 4 cosine to the power of 3 of 5x times, now this one is u, then cosine u prime is minus the sine u, then u prime equals 4 cosine cubed 5x, then minus sine 5x times 5. The final answer is minus 20 cosine cubed 5x times sine 5x. Then back to the original. 15 sine squared 5x cosine 5x times cosine to the power of 4 over 5x minus sine cubed of 5x times minus 20 cosine cubed of 5x times sine 5x over cosine to the power of 8 of 5x. Cancel the common factor, which is cosine cubed of 5x, and that's only 1 is left over. This is 5 equals 15 sine squared of 5x. This is combined together. Cosine squared 5x make positive 20 sine to the power of 4 of 5x over cosine to the power of 5 of 5x. Then take out the common factor, which is 5 sine squared 5x, then 3 cosine squared of 5x plus 4 sine squared of 5x over cosine to the power of 5 of 5x. This is the final answer. Number 6, we can rewrite as cotangent x over 2 to the power of 3 over 2 times cosecant x over 2 to the power of 5. Y prime equals, use the product rule, 3 over 2 cotangent x over 2 to the power of 1 over 2 times cotangent x over 2 prime times cosecant to the power of 5 x over 2 plus cotangent x over 2 to the power of 3 over 2 times 5 cosecant x over 2 to the power of 4 times cosecant x over 2 prime equals 3 over 2 cotangent x over 2 to the power of 1 over 2 times cotangent x over 2 prime equals minus cosecant square x over 2 times x over 2 prime times cosecant to the power of 5 x over 2 plus cotangent x over 2 to the power of 3 over 2 times 5 cosecant to the power of 4 of x over 2 times cosecant x over 2 prime is minus cosecant x over 2 cotangent x over 2 times x over 2 prime equals minus 3 over 2 times cotangent x over 2 to the power of 1 over 2 cosecant square x over 2 times x over 2 prime is 1 over 2 times cosecant to the power of 5 x over 2 prime cotangent x over 2 to the power of 3 over 2 minus 5, then this make together cosecant to the power of 5 of x over 2 times cotangent x over 2 times x over 2 prime is 1 over 2 equals 1 over 2 times minus 3 over 2, which is minus 3 over 4, then cotangent x over 2 to the power of 1 over 2, then this one and this one together, cosecant to the power of 7 x over 2 minus 5 over 2, and this one combined together make cotangent x over 2 to the power of 5 over 2 times cosecant to the power of 5 x over 2. If we want to simplify more, minus 5 over 2 is same as minus 10 over 4. Then you can factor minus 1 over 4 cotangent x over 2 to the power of 1 over 2 times cosecant to the power of 5 of x over 2, then times 3 cosecant squared x over 2 plus 10 cotangent squared x over 2. This is the final answer. This is the last one. We can rewrite as cosine of square root of x plus 1 over square root of x minus 1 to the power of 5. Just think of it as y equals u to the power of 5. Then y prime equals 5 u to the power of 4 times u prime. The inner function is cosine square root of x plus 1 over square root of x minus 1. Cosine square root of x plus 1 over square root of x minus 1 equals 5 cosine to the power of 4 square root of x plus 1 over square root of x minus 1 times, now u equals this one, then cosine u prime is minus sine u, then times u prime. The inner function is square root of x plus 1 over square root of x minus 1, square root of x plus 1 over square root of x minus 1 equals minus 5 cosine to the power of 4 square root of x plus 1 over square root of x minus 1 times sine square root of x plus 1 over square root of x minus 1 times, use the quotient rule, square root of x plus 1 prime times square root of x minus 1 minus square root of x plus 1 times square root of x minus 1 prime over square root of x minus 1 squared equals minus 5 cosine to the power of 4 square root of x plus 1 over square root of x minus 1 sine of square root of x plus 1 over square root of minus 1 times square root of x prime equals x to the power of 1 over 2 prime, then 1 over 2x to the power of minus 1 over 2, which is 1 over 2 square root of x. Then this prime is 1 over 2 square root of x plus 0, then times square root of x minus 1 minus square root of x plus 1 times 1 over 2 square root of x minus 0, then over square root of x minus 1 squared equals minus 5 cosine to the power of 4 square root of x plus 1 over square root of x minus 1 sine of square root of x plus 1 over square root of x minus 1 times 2 square root of x over 2 square root of x. Then expand the first one, the cancelled, square root of x minus 1. The second one is cancelled, minus the square root of x minus 1 over 2 square root of x times square root of x minus 1 squared equals, this one is cancelled, then minus 1 and another minus 1 make minus 2, then make positive, then cancelled. So 5 over square root of x times square root of x minus 1 squared, then cosine to the power of 4 square root of x plus 1 over square root of x minus 1 times sine square root of x plus 1 over square root of x minus 1. This is the final answer. I hope this video has been helpful. This is the last of 6 videos covering derivatives trigonometric functions. Previous lessons are linked in the description bar below. If you have any questions, please leave them in a comment. Thank you for watching. Please like and subscribe for more.